Have you ever wondered what the world is really like at its most fundamental level? Forget everything you think you know about how things work. Welcome to the bizarre and fascinating world of quantum theory. At its heart, quantum theory is the rulebook for the universe at the smallest scales imaginable, the realm of atoms and the particles inside them. Down here, things don't behave as you'd expect. Instead of solid, predictable little balls bouncing around, reality becomes a game of chance and probability. So, why did we even need such a strange theory? Well, back in the day, the classical physics of giants like Isaac Newton worked perfectly for explaining things like planets orbiting the sun or a ball rolling down a hill. But when scientists started peering into the world of atoms, their trusted rules completely broke down. They couldn't explain why atoms didn't just collapse on themselves or how light could knock electrons off a piece of metal, a phenomenon called the photoelectric effect. Classical physics was stumped. It was time for a revolution, and quantum theory was born to solve these deep mysteries. To get a grip on this, let's look at some of its core principles. First up is quantization. Think of it like this. In our everyday world, you can have any amount of water in a glass. But in the quantum world, energy isn't continuous. It comes in tiny, discrete packets called quanta. It's like a vending machine that only gives out full cans of soda, not half cans or quarter cans. Energy comes in specific, indivisible amounts. Next, we have the mind-bending idea of wave-particle duality. This principle says that tiny particles, like electrons, can act like both a solid particle and a spread-out wave. Which one is it? Well, it depends on whether you're looking. When you're not observing it, an electron behaves like a wave of possibilities. But the moment you try to measure it, it collapses into a single, definite point. It's as if the universe is shy and only decides what to be when you peak. This leads us directly to the famous uncertainty principle proposed by Werner Heisenberg. It states that there's a fundamental limit to what we can know. You can know a particle's exact position, but then you'll be totally uncertain about its momentum, how fast and in what direction it's going. Or you can know its precise momentum, but then you'll have no idea where it is. You can never know both with perfect accuracy at the same time. It's not a limitation of our instruments. It's a fundamental property of nature itself. Then there's superposition. Before you measure a particle, it can exist in all its possible states at once. Imagine a spinning coin. While it's in the air, it's not heads or tails, it's both simultaneously. It's only when it lands or when we make a measurement that it settles into one definite state. This is superposition. A quantum particle can be here, there, and everywhere all at the same time until it's observed. And if that wasn't strange enough, get ready for quantum entanglement. What Einstein famously called spooky action at a distance. You can link two particles together in such a way that they'd become a single quantum system, no matter how far apart they are. If you measure one particle and find it has a certain property, you instantly know the corresponding property of its entangled twin, even if that twin is on the other side of the galaxy. It's as if they are communicating faster than the speed of light, a concept that still puzzles physicists today. Now, you might be thinking this all sounds like abstract science fiction, but quantum theory is the bedrock of our modern world. The device you're watching this on right now, your computer, your smartphone, it works because of our understanding of quantum mechanics. The transistors and semiconductors inside are designed using quantum principles. Lasers, LEDs, MRI scanners in hospitals, even nuclear energy. None of these would exist without quantum physics. It's not just a theory, it's the foundation of modern technology. So, what's the simple takeaway from all this? Quantum theory tells us that at its deepest level, reality isn't fixed and certain, but rather a dance of probabilities. It shows us that the act of observation isn't passive. It literally helps shape the reality it measures. The universe is far, far stranger and more wonderful than our everyday intuition can grasp. It's a world built on uncertainty, possibility, and a little bit of spooky magic. Thanks for joining me on this journey into the quantum realm. If this blew your mind, hit that like button and subscribe for more deep dives into the mysteries of our universe. See you next time.